BJ loops like this one look really cool, but they're actually very simple to make within Blender's geometry nodes. So you don't even need AI. We're going to learn how to do this using our traditional human intelligence. With that, let's actually begin the tutorial. In our default scene, we'll bring our cursor to the junction of these two windows, click and drag to create a new window, and then switch this from the 3D viewport to the geometry node editor. Then we'll tap N to remove the side panel and press this plus button to create a new geometry node tree. Now we're going to delete the default cube by tapping the group input and then hitting X. Next, we'll press Shift A and search for a mesh line, which we can eventually convert into our Sci-Fi triangular grid. So when we actually plug this mesh line in, you see it's going on the wrong axis. We can fix that by changing this offset to be a value of 0 on the z-axis and then changing it to whatever we want on the y-axis. For now, I'm going to keep it at a value of 2 on the y-axis. Apart from that, I want there to be many more rather than having just 10 points. So I'm going to increase that to something like 40 so that it is a lot longer. Now, the reason why we're using a mesh line instead of using a curve line is so that we get access to this count, because that's going to determine the actual resolution of the grid. If we were to use a curve line, we would have to then again resample the curve line to determine the resolution. So both of them use the same number of nodes. So you could use the curve line instead, but I'm going to choose to use the mesh line and then convert it using a mesh to curve node and then converting it back to a mesh by using a curve to mesh node. So we've taken a mesh, converted it to a curve, and then converted it back to a mesh so that we get access to the profile curve. This is what's going to let us create that triangular tunnel. But remember, a triangle is just a circle with a resolution of 3. So we can press Shift A and search for a curved circle and then simply change the resolution down to 3 and plug that into the profile curve. So now we have our triangle. However, we don't actually want this to be a triangle, we want this to be a grid. Let's actually see the grid by converting this back to a curve by pressing Shift A and searching for a mesh to curve node. Now, if we actually look at this mesh, you can see that the resolution is not too high. We would want some lines to go through the middle as well. So to introduce those lines, we can press Shift A and search for a subdivide mesh node and plug that in right after the curve to mesh. So now we can increase the level to something like 2 and you see we get a really nice grid of lines. However, if you feel like the grid is too crammed on the y-axis, you can go ahead and play around with this offset to increase the distance or reduce the distance, as you can see. However, I think a value of 2 is perfect for the application that I want. The next thing that I want to do is actually create the animation before adding in the other elements to enhance this animation. So for the animation, the next thing is if you actually switch off the overlays, we can't see this because this is still a curve. We need to convert this to a mesh once again. So we're going to press Shift A and search for another curve to mesh node and plug that in right before the group output. And for the profile curve, we can simply duplicate this curved circle. So let's just select it, press Shift D and plug that into the profile curve. However, the scale is way too large, so let's reduce the radius down to something like 0.01, and that should be perfect for what we want. Now, even with the overlays off, we can actually see the grid. Now, before adding in all of the next secondary elements to enhance the animation, let's actually create the animation. For that, I'm going to actually be using the camera and animating just the camera. So let's select the camera, press Alt-G to clear its location, Alt-R to clear its rotation, and then tap RX90 to rotate it on the x-axis by 90 degrees. Next, to set up all of the animation defaults, let's go to our output properties, change the resolution to 4K by changing the slider to 200%. I want it to be a 60 FPS animation, so I'm going to change this to 60 FPS. I'm going to change the end frame to 600 so that it's a 10-second long animation. While we're at it, we'll change where we save the output file. So / saves it wherever the blend file is saved, so don't forget to save your blend file. Then the file format, I'm going to choose FFmpeg video with the encoding container changed from Matroska to MPEG-4 and an output quality of perceptually lossless. Then in my camera properties down here, remember you have to have your camera selected to actually get the camera properties. I'm going to reduce this focal length down to something really small like 12, just so that it looks a lot better. You can actually see what that looks like by going into the camera view by pressing this little icon over here. As you can see, with a focal length of the default 50, it looks a lot more packed as compared to when it's at a focal length of 12, or you could go even lower to something like a focal length of 8 if you want. However, I think I'm going to go with a focal length of 18 for now. The next thing is, instead of animating this object moving forward like that, I'm instead going to have the camera itself move back. So because I want some of this to be present even after I move the camera back, I'll just take this object, press GY, and then move it by, let's say, -10 units. And remember, we moved it by -10 because we had to move it in the negative y direction. Next, we take this camera by just selecting it, and then we can increase the timeline, go to frame 0 and tap I to add in a keyframe. And then all the way at frame 600, we can go ahead and just press GY -10 and then tap I. Now, if we were to actually watch the animation, you'll see there's two things that happen. First thing, it starts off slow, speeds up in the middle, and then slows down towards the end again. That's because the default interpolation is Bezier, so we can just hover down here, tap A to select both the keyframes, and then tap T and choose linear. That way, it becomes a smooth speed throughout the animation. The next thing is, this kind of just looks boring because it's only moving straight back. To give it some more flair, we can actually have this rotate, and we can do that by simply rotating the camera. So on frame 600, we can rotate the camera on the y-axis by 360 degrees to make one full rotation. However, because this is a triangle, we get trifold symmetry, and we can make it a perfect loop by just rotating it around the y-axis by 120 degrees instead of 360. So now if we just tap I, we can see that now we have it rotating over time as well, which is perfect for what we want. And if you go towards the end, you'll see that it is a perfect loop. You cannot actually tell when it stops and when the next loop ends. The only problem is all the way down there, you might be able to see a tiny little difference, but we're going to fix that real soon, so we don't have to worry about that for now. The next thing is going to be adding in those little particles that are going to be moving towards the camera. So in order to add those in, we're going to use another object, and we're going to use geometry nodes. So let's press Shift A and search for another mesh cube. It could be any mesh primitive because we're going to be changing it in the geometry node editor anyway. So let's press this plus button to create a new node tree, select the group input and tap X to delete it. Next, we'll press Shift A and search for an icosphere and simply plug the mesh into the group output. Next, we're going to make this a lot smaller. So let's change the radius to something like 0.1, and I want it to be scaled up on the z-axis so that it looks like a smear. So let's press Shift A and search for a transform geometry node, plug that in right over here, and simply scale it up on the z-axis by something like 7. Next, since we're actually moving on the y-axis, I need this to actually be elongated on the y-axis, and we can do that by simply rotating it about the x-axis by 90 degrees. Now, this gives us one single shard, but we need more of them to be going on all of the faces. So what we can do is, instead of directly using this, we can create the same object that we created for this using the exact same logic and then instancing this on the faces. So let's go ahead and do that. Let's just remove this from the group output and then press Shift A and search for a mesh line, plug that into the group output. Now we want this to be on the y-axis again, so let's tap 0 on the z and make the y-axis value as 2. And then I'm going to increase the count to something like 20, as that should be enough. And then I'll press Shift A and search for a mesh to curve node, and then convert that back into a mesh by pressing Shift A and searching for a curve to mesh node. Once we have that in, for the profile curve, we're going to use another curve circle. So let's press Shift A, search for the curve circle, and plug this curve into the profile curve. Remember, we want it to be triangular, and that has a resolution of 3. So let's just reduce this down, and that should be good. Now, if we were to instance these onto all of the points, we might get what we want, but you'll see the small caveat once we do that. So let's press Shift A and search for an instance on points node, plug that in just before the group output, and use the object that we created with the icosphere as the actual instance. So let's just take this output and plug that into the instance. So once we have that, you'll see that we do have them, but the problem is they're on these faces. We actually wanted them to be on the faces of the triangle and not on the edges. If this is what you want, well and good, we could actually keep it as it is, but I want them to be on the faces. So what I'm actually going to do is maybe have both. So let's keep this, press Shift A and search for a join geometry and plug that in right over here. Let's go ahead and shift this down and then press Shift A and search for another instance on points node and keep that just above the first instance on points node. Now for the points, instead of using these points as is, what we can do is we can search for a mesh to points node, plug that in, and then take this mesh output, plug that into the mesh to points node, and instead of having all of the vertices, we can change it to faces and then plug that into the points. For the instance, we can use the same exact instance as is and then plug this into the join geometry. So now you can see we get them on the faces as well. So that might look cool, but I think the problem now is that they just look a little too large. So we can reduce the scale by going ahead and changing the radius of the icosphere down to something like 0.05 instead of 0.1, and that should make them a lot smaller. And now all we need to do is get these to actually be moving towards the camera. And we can do that using a simulation zone. So let's go ahead and just press Shift A and search for a simulation zone and plug this output from the join geometry into the input of the simulation and the output of the simulation into the group output. Next, we want to move these on the y-axis every single frame. So we press Shift A and search for a set position node and simply move these on the y-axis. And remember, we needed to move on the negative y-axis to move towards the camera. So we're going to move it by maybe something like minus 0.05 on each frame. So now if we actually play this animation, you can see they are moving towards the camera, which is perfect. If you want to speed up the animation, you can change this from minus 0.05 to a value of minus 0.1 and then play the animation to see it go a lot faster. But I think a value of minus 0.05 was good enough for me, so I'm going to keep it as is. If you want it to be even slower, you can reduce this value even more. Now that looks good, but something's going to happen. As we play this animation, points at the back are going to come towards the camera, and eventually if this animation was long enough, there would be no more points at the back. So in order to prevent that, what we can do is simply ensure that if any of these particles go behind the camera, they should instantly get respawned right at the back over here. So first we need to check if the particle has gone beyond the camera. To do that, we can just drag in the camera from this collection into our geometry node editor by dragging and dropping, or you could search for an object info node and then choose the camera from the object menu over here. Now we have the location of the camera at every single point, but because the camera is moving, we're going to have to use the relative option. Now we only care about the y-axis position of the camera. So to get access to the y-axis position, we can press Shift A and search for a separate XYZ node. Now we can take this location, plug that into the vector, and now we have the access to the y-axis of the camera. But now we need the y-axis of each of these points as well. So we press Shift A and search for a position node, which will give us the position of every instance. Next, we need the y-axis coordinates. So we're going to just take this separate XYZ node and duplicate it by pressing Shift D. Now let's plug this in and we have access to the y-axis values as well. Now let's press Shift A and search for a compare node so that we can actually compare the y-axis values. And if the y-axis value of the camera is greater than the y-axis value of any of these points, then the points should go back. So to make them go back, we can search for another set position node or just duplicate this by pressing Shift D and then offset it on the y-axis by the entire length of this series of points. Now this entire length is equal to 2 meters times 20 because there's 20 of these each at a distance of 2 meters. So we can go ahead and change this to be a value of plus 40 meters and then plug this result into the selection. Now let's go ahead and play this to see if our logic works. Now you can see that clearly works, but there is a tiny little gap created right at the beginning. So that particular gap is happening simply because these points that were created on the faces are clearly not present at the edge of the original triangular tunnel. So that's why there's an equivalent of one missing right over here and one missing right at the end, which doesn't appear in this position. So what we need to do is actually push it back by just one of these units lesser, but only for the ones that were created on the faces. So what we can do is we can press Shift A and search for a store named attribute node and just store an attribute that states that these instances were created on the faces. So instead of plugging that in here, let's just alt click it there and let's just store an attribute called faces. We're going to have the attribute set to true. So it's going to be a Boolean attribute. It's going to be stored for every instance and the value is going to be true. So now what we can do is we can set the position pressing Shift D, and instead of this, what we're going to do is push it forward by just -2 units if and only if this is true and faces is true. So we press Shift A, search for Boolean math, check if this is true and search for named attribute. We want it to be a Boolean, name is faces. We just check if faces is true. So let's go ahead and plug that into the selection. And that still did not work because once this gets pushed back, this is no longer going to be true. So we're going to have to push it back over here itself. So what we can do is just press Shift D and then ensure that and this is not true. So let's press Shift A, search for not, plug that in right over here, and that should be taken care of, and then use this in over here. So now that should hopefully work. And now it's not working because it's getting pushed away because it's only looking at this. This should actually be a a value of 38, which is 40 minus 2. So now if we go back to frame 0 and play the animation, it should appear here to fill up that gap. So now that looks perfectly all right, and it seems to be working. So we don't get that gap at any point of time, even if it is going to cross the camera. There clearly is going to be a tiny discrepancy for the first few frames over here, but remember, we are going to be cutting it off at some point, so that section doesn't really matter. It should only have no gaps when it crosses into the camera view. So that seems to be absolutely perfect, and it'll create a perfectly seamless loop when we actually animate this. Now, the next thing that I want is some sort of a triangle that's going to be present at some distance from the camera, beyond which everything's going to be clipped away. So let's do that by using another geometry node object. You could easily do this without geometry nodes, but I feel like since we've used geometry nodes for everything, I'm going to use geometry nodes for this as well. Let's press Shift A, Mesh Cube, new geometry node. Let's delete the group input, press Shift A, search for just a curved circle, plug that into the group output, and now resolution is going to be 3, and it has to be rotated to match this orientation of our grid. So in order to rotate it, let's press Shift A, search for transform geometry, plug that in right here. Let's rotate it on the y-axis by 90 degrees, and then rotate it on the z-axis by 90 degrees. And now we want to rotate it again. So let's press Shift A, search for a rotate or a transform geometry, plug that in right here, and then just rotate it on the y-axis by 30 degrees. So that's going to make it perfectly line up with the grid that we have, but we want to give it some thickness because right now it's just a curve. So to give it thickness, we're going to press Shift A and search for a curve to mesh node, just like before. But this time for the profile curve, we're going to use a curve line. Let's go ahead and plug that into the profile curve. And now we have to choose the right axis. So clearly the z-axis is not the right axis. Let's change that to 0 and just increase it on the y-axis so that you can either get it to go outward like that or inward. So I actually want it to be inward by a bit, maybe not this much. Minus 0.25 should be good enough. And that gives me the shape that I wanted. Now to make this follow along with the camera, I'm going to add a constraint. So I'm going to go over to the constraints, add object constraint, and choose copy location. For the actual target, I'm going to choose the camera, and I'm going to choose only the y-axis location. Next, I'm going to press this offset, and I'm just going to press GY and move it back to whatever distance I want. So maybe a value of 15 would be good enough. So let's actually go into our camera view, and it's going to be that far off, which seems to be perfectly all right. So now, if you actually see it, it's going to move along with the camera. Now we need to delete anything that is beyond this particular cube. And that's actually going to be done using a very simple hack. Back in the camera properties, we're going to select the camera, go to camera properties. We're going to choose this clip end to be really low just until that particular cube. So anything beyond that is no longer visible. So we just increase it till the object that we just created is visible, and everything beyond that is clipped off. So now it looks like everything is emerging from that object, and we get a perfectly seamless loop, and we don't see anything beyond that. So I think that looks great. The last thing left is texturing and then compositing. So we're going to have to add in the materials in the geometry nodes for each of these objects. So let's go ahead, move this group output to the side, press Shift A, search for a set material node, plug that in right before the group output, and we can choose the default material. Let's go over to the material properties and rename this to grid. Next, we need to create something for these particles. So let's, again, just before the group output, press Shift A, search for set material, plug that in right here, press this new button to create a new material. We'll call it particles, and then choose that over here. Lastly, for that final object that we created at the end, we can go ahead and press Shift A, search for set material, plug that in right over here, and let's create a new material by pressing this. We'll call it end, and then we'll choose end over here as well. Now to actually see the changes, we're going to bring our cursor up here and change our viewport shading to rendered so that we can actually see it. Now we don't need the light, so let's just select the light and tap X to delete it. And then we can change our geometry node editor to the shader editor. Now for the grid, I'm just going to use a simple emissive texture. So let's delete the principal BSDF, press Shift A, search for emission, and then plug the emission into the surface. As for the color, you can choose whatever you want. I'm going to go with this sort of a retro purple, and I'm going to increase the strength to something like 5. Now to get a nice little glow from now itself, I'm going to switch on the compositor, switch over to the compositor workspace, press use nodes, press Shift A and search for bloom, and just plug that in right after the render layers. Now I'll go back to the shader editor, and to not see anything outside my camera view, I'm going to select the camera, go over to the viewport display, and choose pathbar 2 all the way to 1. Now you see the gray doesn't really look good, so I'll go over to my world properties and change the background color all the way to black, and that looks great. Next, I'm going to select cube 001, which is the particles, and even for the particles, I'm just going to press Shift A, search for an emission node, plug that into the surface, and this would be maybe a bluish color, and just increase up the strength. Now, if you don't want to do this, something else that you could do for this is pressing Shift A and searching for a layer weight node and actually mixing it in with something else. So search for a mix shader and maybe a principled BSDF itself, and now mix this in using the Fresnel value of the layer weight. That's going to go into the factor, and for more control, you can press Shift A and search for a color ramp node, plug that in right after the layer weight, and now by just crunching these values in or out, you can get like really cool effects. And you can play around with this blend value as well. So I think that looks pretty good. I'm just going to increase the strength to something like 10. Now I have some texture to it as well. Lastly, I have the final grid at the back. That's also going to be emissive. So let's press Shift A, search for emission, plug that into the surface and change this color to be whatever suits the requirements and increase this to maybe a value of 10. So that's actually all there is to create these super cool retro styled neon grid animations. Once you're happy with the way everything looks, you can go ahead and press render animation. I hope this tutorial was easy and taught you a way of thinking with nodes to create really cool animations that are customizable, reusable, and most importantly, creative from a human standpoint. I think it's very important to start understanding how everything works within softwares like this, the algorithms being used, and the actual innovation and creativity that goes into building softwares like this itself. So I will be focusing on a lot of deep dives in the upcoming few weeks, but until then, there will be quite a few tutorials and hopefully a short film if my laptop allows me to render it without continuous crashes. But until all of those come out, thank you so much for watching. Definitely check out the Demystifying series and so many other tutorials on my channel. And until then, keep creating and don't forget to stay creative.